Recently I got tagged in this meme. It is a coffee machine that is controlling a modular synthesizer, Eurorack in particular in this form. In this meme, this Europot only has one CV output. We can assume this is probably for temperature. It could be for anything really. It could be sending triggers when it's done or nutritional information via analog signals. We just don't know, but I'm going to assume it's the lowest common denominator, which is temperature, which happens to be a very nice and simple project, which even without electronic experience could be a simple project to sink your teeth into, with or without a coffee machine. In front of me we have a 9-volt battery. In fact, to make it simpler, we've got this 9-volt battery clip. We're going to pop it into there so we don't need to keep on alligator clipping the 9-volt battery. We're going to turn on the voltage meter onto DC for the volts. We're going to measure the voltage of the 9-volt battery. We'll get some crocodile clips onto the 9-volt battery. Sorry, I mean alligator clips. And let's plop it on there. Oh, this is getting messy already. Oh. Right, we got 9.75 volts. So first we're going to talk about the principle of wiring these things up. This sends out 9.75 volts. However, we're going to plug it through this, which is called a potentiometer. It's a variable resistor, and what it looks like in component form is like this. Go like this. We're going to draw a wiggly line, and then we're going to draw an arrow. So right now, this leg is here, this leg is here, and this leg is here. Mechanically, there's a really long flat resistor that connects this leg over to this leg, and it is at the value in this case of 10k. This middle leg is on an arm and it can select anywhere between this leg and that leg on this resistor. So we're going to measure the resistance now. Okay, it's about 10.99, so it's closer to 11k. We're going to plug it into the middle leg now. We're going to twist it, so we're going to twist it up, and as you can see, it is slowly rising in k-ness, in resistance. As I turn the pot up, it goes all the way to 10k. The further around it is on the resistor, the more resistance there is, because you've got more resistance to go through. In fact, let's just quickly have a look on the inside of one of these, just to show you, just to get rid of all of the mystery. So this black bit is the resistor, and then obviously this is the arm bit that touches onto that resistor, and then touches this ring which connects it to the output of the central leg on the potentiometer. These potentiometers obviously come in lots of different shapes and sizes. Practically, this resistor reading isn't much use without electricity going through it. So we're going to go back to the volts, and as you can see, there's no volts because there's no power attached to it. So that's when we need to get this. Now we're going to wire the ground of the 9-volt battery into the voltmeter. Then we're going to plug the 9-volt battery through this variable resistor. Now you can see we've got the 9 volts on the voltmeter. However, when you adjust it, nothing happens. Nothing's happening. What's going on? What's going on? Well, that's because we need to make something called a voltage divider. We have the output that's going to attach to the multimeter, to this bad boy over there. And we're going to attach the 9-volt battery's minus over to one side of it and the plus to the other side of it. But we're also going to wire the minus over to the minus, the black connector of the multimeter. So these three are connected to ground, and then the plus goes through the resistor. So to do this, we get the red wire from the 9-volt battery, pop it onto the leg of the potentiometer. Then we get another crocodile or alligator clip, connect it to the black wire of the 9-volt, which is also connected to the black wire of the multimeter, put it on this side. So now we can select any voltage between the ground and the 9 volts via this output. So we're going to find the red connector of the multimeter, connect that up to the middle leg. Oh, yep. And now we're on 9, and we can just twist it down and go down in voltage to any of the voltages between 9 and or whatever's in the input to 0. If instead of plugging this into a multimeter, we possibly have a synthesizer that we can plug it into, like in the meme, then we can do that. I've got this Cosmo Eurorack oscillator, and we're going to get a mini jack cable in this instance. We're going to cut it in half. Ooh, and we're going to strip it. Now we've got a black wire in this cable and a red wire. Disclaimer, if you decide to do this, whilst there is a very small chance that you'll break something, you might break something, so do it at your own risk. Anyway, so now we've got this, we'll do it again. We're going to get the black wire this time into this side of the potentiometer. Now we got that wired in. And then we're going to get this one. We're going to get the red side. We're going to use a crocodile clip again. Get the red side of this and crocodile that to the middle leg. And then we'll get the black crocodile clip and plop it onto the black side of this cut off wire and get that onto this black leg again, like so. Now we can plug the output of this into the voltage inputs. Whoa. If we plug it into the voltage octave, in theory, because there's 9 volts, we've got 9 octaves, which is just silly. We're going to get the dogs barking. Oh! Now you may or may not know that this is how a lot of the knobs on modular synthesizers and other electronics actually work. But instead of a 9-volt battery here, we've actually got the input cable going into it. So we're going to have the picture of the input cable. We've got the input cable here. The tip of it, which is the signal, we're going to draw the plus, even though sometimes it isn't plus. And we've got this, which is the ground. We're going to call that the minus. We're going to wire the ground into this. And we're going to wire the signal, which is the tip of it, into this. So instead of a 9-volt battery, we're going to actually have another voltage source. How do we do that practically? Let's get it done now. Where's the other side of that jack socket? Instead of the 9-volt battery, we're going to wire the other side of the jack socket onto this. So the red wire on one side and then the black wire. It's a lot easier if you're soldering, but whatever. This is the input cable. This goes into the output of something else you want to adjust the level of. And then we get the input cable, which is right here. We plug that into the input of this one and connect it the same onto this leg. And then we get the red one and connect it onto the middle leg. Whoa, 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 get it on the middle leg. On the middle leg. Well, hey. Now let's see what it sounds like. Now, instead of the voltage being a solid voltage from the 9-volt battery, you're getting a varying voltage from the output of this synthesizer. That goes into here as a signal, and you're using this potentiometer to adjust between the full signal and ground. In this very simple voltage dividing situation, this is basically a volume knob. It's actually how a volume knob on a guitar is wired. It's just a voltage divider. Anyway, why are we talking about this? Because to make this coffee pot work, we need to use this concept. We're going to be using a sensor which is a thermistor. It's a variable resistor that is sensitive to temperature. And we're going to use this variable resistor in place of this potentiometer. In this bag are a few different thermistors. We've got 100k ones and 10k ones. I think we're going to actually use a 100k one in this instance, but it doesn't really matter. You just got to mess around. Let's take one out. Oh, little tiny little babies. Right, so these are little thermistors. You'll notice that they're actually only got 2 legs. So we need to use a different circuit entirely. Well, not entirely, that's a joke. So we've got this, which is a thermistor. I can't remember the component drawing for a thermistor. I'm going to draw a resistor, and then I'm going to draw a sun over the top of it, just because I can't off the top of my head remember the symbol. So we got the thermistor here. What we're going to do is we're going to use it very similar to this, but we've only got 2 legs. So what we need to do is actually put another resistor on this side and pretend we're only using half of the potentiometer. So we're going to use this 10k resistor right here. We've got this thermistor from another sister right here that will connect over to the 9-volt battery's positive. So we've got the 9-volt battery connecting here. Here's the 9-volt battery. And then we're going to have the output over to the synthesizer right here. This is the signal, but remember we've also got to attach the ground cable to it. So that's the 2 wires going off to the synthesizer over there. For demonstration purposes, because a thermistor is quite a bit slower functioning, we're going to use a light dependent resistor. This is like the thermistor, but instead of heat, it's going to be sensitive to light. Resistor, going to twist the legs together because we're not going to use solder in this video. We're going to use the 9-volt battery. We're going to put the red wire on this side, and then we're going to put the black wire on this side. We got this circuit here, Whoa, whoa, try and keep it up in line. We'll quickly show the output via the multimeter, just because it's here. We'll put the signal, which is this middle bit there, and then plug the ground of the multimeter to the negative. Right, we've got 8 volts on here. If I cover it up, it should change. Right, we're down to 1 volt, so 7 volts, 2 volts, and we could get everything in between because we're adjusting the amount of light that goes through this resistor. Now, instead of wiring in the multimeter, we're going to wire in this jack socket. So we got the black wire connecting to the black crocodile clip, and then the red wire connecting to the red crocodile clip. Now we're going to wire this into the synthesizer again. Plug it into the CV. Now that is the LDR. As you can see, it is fun in its own instance, but we can't use that in this because it's not very sensitive to temperature. So, well, it is, because if you look at light as, you know, a bit of all radiation in the end. So we're going to get this thermistor now. Now in theory, if we adjust the temperature around this, we'll be able to change the pitch. Oh yeah. Okay, it's not as quick running as an LDR. I don't think I'll be able to use this to play Rick Astley quite the same, but it's enough to turn a coffee machine into a voltage source. In the meme, it's one of those filter coffee machines, and they're not that popular in the UK, so I couldn't actually find one really quickly. So I've got this random coffee pot thingamajib, but it's enough to show the concept, so if anybody wants to take it further, by all means do so. Right, it's as easy as taping the thermistor onto the coffee machine. No idea if this is in date, but it'll have to do. Right. I don't know how to use it. I guess it sort of works, so now I'm going to make it a little bit more permanent and make it sound a little bit nicer. What I've done is I've basically soldered that circuit together and super glued it onto a piece of wood. There is also a piezo speaker. It's just a piezo speaker wired to a jack socket, because I figured why not, we can also get some audio from the coffee pour. Throwing up a stone. Oh, baby.
that's it for this video. I think it worked out quite nicely. If you want to see the full brew and hear the full brew, well, it's available over on Patreon if you want. And needless to say, going over there helps support all of these videos and such. And I'm working on a couple of other rather large ones. The videos won't be out in a little while. I'm talking about those in detail over there. So if you're curious about any of that, then go and check it out. I'm going to try and figure a way of integrating this temperature control into the museum. So if you're interested in that. Anyway, don't forget to subscribe. You know, we'll see you never could subscribe. Don't forget to try it. Lovely.